Welcome on today's screencast. Today I'm gonna show you how to write a simple XMLRPC server and XMLRPC client in Java. We're gonna use Apache XMLRPC library in the newest version available, which is 3.1.3. That might not be the version you've downloaded. If you've downloaded a jar from I don't know, from a portal or from another place, you probably have a different version. I'm gonna use 3.1.3 for this exercise. So the goal of today's screencast is to show you how to write a very simple XMLRPC server and a simple XMLRPC client. Now, we are also gonna do a little bit of tracing. So we're gonna run Wireshark and look at the messages sent between client and server. So I'm gonna run both in a single process, in a single machine, in two processes inside my IDE. So I'm just gonna create a server class and a client class and run them both and see what happens. And that's pretty much okay, because running things on separate machines would only complicate the setup, and I wouldn't be able to run the screencasts smoothly. I would have to log into something and well, that would generally be much more complicated. And the only difference would be that I would have to bind to a different port and maybe do some discovery. And that's not really worth it. Okay, let's start. So we start with public static void main args. And we're gonna create a web server. This is something that is embedded inside XMLRPC, which is a new web server, and we're gonna start it on port, say 8741, because why not? The port doesn't really matter. On Linux machines, if you wanna bind to a port below 1024, you need to be root for historical reasons, but basically other than that, it's not important. Now then, we need to create a mapping for our handling procedures. So we need to be able to call something on the server. And to do that, we have something that's called property handler map. And here we need to add handlers. And our handler in this case, we're gonna call it maybe server. Why not? And we're gonna have a server class here. And this is XMLRPC exception, might throw XMLRPC exception, so we just bubble it up to the main and the application, if it throws, it won't throw. So it doesn't matter that much. Now once we added the handler, we need to actually set the mapping on the server. So we get the XMLRPC server and set the handler mapping. And in the end, we start the application. And this is an IO action, so it can throw an IO exception, which we also bubble up to, and it ends the application if there's something wrong. For example, the port is already bound, which is, by the way, if you cannot bind to this port, it usually means that it's already bound, and you can debug that with netstat. In case of Windows machines, that would be netstat abo, and in case of Linux machines, this thing, pulpn as root, so usually that would be sudo, will give you an information which process is listening on this socket, and then you can just go and kill it. So let's have an echo function here that will take a string argument, and that will print it out on our server. And then it will return a pong. So it's a very simple function, and we will be able to call it using this from the external client. Now it's time to write our client, and our client will be at first equally simple, which is public static void main string args. I'm not gonna add throws and any throw clause here. So we want to do something that is extremely simple. So we want to create an XMLRPC client, and we'll call it RC, and this will be a new XMLRPC client. And then our RC, we will want to execute a function, and this function is called server echo. And it needs, of course, an argument, a singleton list of hello XMLRPC. Now, execute is an IO exception and actually an XMLRPC function, so it can throw an XMLRPC exception. And in our case, it returns a string. In general, it returns an object, so we need to cast it to whatever we need, which is pretty bad news because we need an out-of-bounds information of what does this thing do. Out-of-band information. And now we want to have this as a result, and of course we want to system out println that. Now the thing is that we still don't know where is our servers, because we only have a client, and this client doesn't know where to connect to, and we need to pass this port somehow. So what we're gonna do is we're gonna create an XMLRPC client config impl, a config which would be a new client config impl. Then we're gonna set server URL, which is a new URL, and now HTTP is the standard thing because this thing communicates through HTTP. So this sets up an HTTP server on this port. So that's why we start with HTTP. Now I'm gonna use my internal IP address, and this is not exactly the standard IP address, because you would expect 127.0.0.1 or something like that. Now I'm running that on Windows, and Windows doesn't really like you to listen to 127.0.0.1. So I'm running through npcap address set up by the Wireshark, so that I can intercept the messages, so that we will be able to see them in a second. Usually I would just write something like localhost, and that would be fine enough. Okay, now next we need to set the config. And we're pretty much done here. So let's run it. Okay, so our server is running. Now let's run our client. Okay. Oh yeah, of course. The server, as I said, the problem is that the server cannot bind to the same port, and I've already started that during the earlier class. So I have to stop the process before running it on elsewhere. So this should be okay now. Yeah, so we have hello XMLRPC, and we have here hello XMLRPC. So this one obviously came from server because we have Pong here in a prefix. And here on the server process, we have hello XMLRPC, which means that we did communicate. Awesome. Now let's see what happened. On the network. So right now I've started listener. So I'm running that, and let's see what happened on the network interface. So on our interface, what happened is we got two messages. So one is a request and the second one is a response. So the request is a post request that goes through HTTP 1.1, and there are some headers. Accept is a pretty interesting header. It pretty much means that it's just not configured well enough. But the default values is pretty surprising, I would say, to say the least. Now, here is the actual payload. So we have our payload in XML. So we have method call, method name, server echo, params, param, value, hello XMLRPC. As you can see, that's even this XML representation of the message is quite long, to say the least, comparing to those two items that are the only ones that change. So actually those are the only two variables in the entire message, and they take something like 30 bytes or something, maybe a little more, maybe 40. Let's say those are 40 bytes, comparing to the file, to the XML that takes nearly 160 bytes, and the whole message that takes 240. That's quite an overhead. And you will find that in several network protocols, especially text-based ones and HTTP ones. So if you communicate via HTTP, you're likely to have this overhead. Now, I'm not going to mention that the TCP packets took over 400 bytes, right? Because on the Wireshark can also be used to intercept TCP and IP messages. So you have all these byte by byte what happens. So that's a pretty awesome tool. And then we have our response, and response is even worse, to be honest. It takes over 300 bytes, and the only reasonable part is this thing, Pong hello XMLRPC. So that's what happens on the network. Now, you might want to take a look at this thing. We get an OK response, which sounds reasonable because our request succeeded, right? So now let's do something that will not succeed. So say we change our client to access server instead of server. So we will obviously get some error here, XMLRPC exception, no such handler, which makes sense on the client side. On the server side, nothing really important happened, just some error, nothing to do. But look what happens on the network. You got a post that is server, pretty similar to the previous one. And we get our error, but we get this wrapped in a 200 OK response. And then we have method response, fold, value, struct, member, blah, 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 blah. That's quite a complex structure, considering that the only thing here is the name of the fold and the value and the code. So that's quite a complex response, but that's basically what goes through the web. So when you communicate through the web, these kinds of packets go there and forth, and that's why you might want to use a little bigger communications. So you might want to prefer the document-based communication. So this is something that is advocated by the REST community, that you communicate via document. So document is something that is fairly big comparing to the RPC mode, which which uses just methods and parameters which are generally, well, they have more overhead due to the protocols, to the network protocols. And if you communicate based on documents, those documents are generally bigger, so if you need more information, that might be a better approach. Right, so that's the most important thing. That's how you do the synchronous communication. Now there is one more thing that I will show you how to do, and which is asynchronous communication. And in the case of XMLRPC, this is really really bad. I'm gonna tell you why. Because here our async callback doesn't have, by default, we don't have a way for waiting on that. So we need to have an async callback, which makes sense because as soon as you have something that is async, you need to wait for it. You need to call something when it's done. And our async callback has handle result and handle error, but what our async callback does not have is it does not have any wait for function. So we don't know if it's ready or if it's not ready, or should we wait, or is it done, or what happens. So if you wanted to implement that in a real life scenario, and you might want to, because why not, then what you would do is you would also add some function here that would poll the results. So you would enable, I don't know, maybe a promise or another thread that would verify the async callbacks if they're ready, and then once all of them are ready, just finish or join them or do something like that. It's also fairly, so you need to also make sure on which thread those run, so that's not very simple to manage. And we're not gonna manage that here because we don't really have enough. Well, it's pretty much out of scope. So we're just gonna do a thread sleep for 10 seconds. And we're gonna implement it 10 times, and then we're gonna have this AC. Now what I wanna show you is, I don't want that. What I want to show you is that if we run async queries, async calls, the difference is we didn't change anything on the server. Server is still the same. Oh yeah, hello XMLRPC, but we also wanna I here. So what I want to show you is that the responses come in a pretty random order. So they're sent, and then in some order they are handled somehow. But you know, the order is not that well defined. Now it is defined here. So what happens is each of those gets a separate HTTP connection. As you can see here, the source port, it differs. So each source port that is different, that basically means that those are every one of them is run by a different connection. And that's okay, but that also means that we get a random order of responses. If we just run execute like that, so we wouldn't have these AC here, and here we would have system out print line. We would have everything in order. Yeah, as you can see. So we wait for 0, then we run 1, then we wait for 1, etc. One thing that is worth mentioning here is that if the calls are longer, so say you have to wait for 5 or 10 seconds, Then if you do them synchronously, then you have to wait 50 times 5 seconds. And in case of running them asynchronously, then you just wait these 5 seconds because they all wait in the same time. And that's a pretty important feature. Now, something that you might want to consider, that actually many systems that talk about running in parallel or concurrently, they're actually talking about concurrent waiting. And on that note, I want to say thank you for watching, and have a great day.